This is 2.4b, factoring and solving quadratic equations. So we've talked about factoring a little bit already. We're going to go into factoring again, and we're going to talk about how we can actually solve with factoring. So we're actually going to move into the solving piece, not just the factoring piece. And we're going to talk about solving with a different method called the square roots, solving by square roots. Okay. So first of all, your essential question, once again, remember that is what you're answering with 3 sentences at the end in your summary. How do you factor and solve quadratic equations? So while we review solving, we also need to review the factoring methods. So remember, first, always look for GCF. Second, if it has 2 terms, look for a difference of perfect squares. And third, if it has 3 terms, look for trinomial factoring with or without coefficients. Okay. So when solving, remember that the equation needs to be set equal to 0. Always has to be equal to 0. Step 1, always make sure it equals 0. If it's not equal to 0, you cannot use the solving method, which is the zero product property. This is a key property. You've done this a lot throughout math, and maybe you've never learned why. Okay. So the zero product property says if A times B equals 0, then A equals 0 and or B equals 0. One of these things must equal 0, right? Because anything times 0 equals 0. So if we need it to be equal to 0, either A or B must equal 0. And that's our 2 solutions to this, right? A equals 0 or B equals 0, okay? So when we're talking about factoring, we set up multiple things, usually 2 pieces, sometimes more pieces, that are multiplied together, and as long as one of those things ends up equaling 0, it becomes a true statement, right? So for instance, if I had 2x times 3x minus 1 equals 0, that is 2 things multiplied together. I have 2x, that would be considered my A in this case. My B would be 3x minus 1, that whole binomial equals 0. As long as one of those is true, it will equal 0, right? Because if I take 2x and I plug 0 in instead, if I distributed 0, it would equal 0, which is what we want. Or if I took the 3x minus 1 and replaced it with 0, 2x times 0 is 0. So that is what the zero product property is telling us. And that's a very, very important thing for solving. That's why it must equal 0 first. If it doesn't, there's no 6 product property. There's no -2 product property. There is only the 0 product property. Okay, so that is a key thing for solving. Once we have them 2 things multiplied, we set them each equal to 0 because as long as one of them equals 0, the statement will be true. Okay? So, number 1, we always look for GCF first. I can see they both have an x and they both have a factor of 2 involved. So I'm going to take out a 2x. Okay? And I would get 3x minus 11 left. Okay, if you are having trouble with seeing that, break it up. So 6x squared, that 6 breaks up into a 2 and a 3. The x squared is an x and an x, so I have a 2, 3, x and x. And then the negative 22x, well, I guess just the 22x, we'll just focus on that. It's going to be a minus in between them. The 22 breaks up into 2 and 11, and the x is just x. So you can kind of see, if I take out my common factors, which are 2 and x, I'm left with 3x in the first one. And I'm left with an 11 from the second one. So that's where this comes from. I took out a 2x in front, and I have 3x minus 11. And notice, I put it in front and I'm multiplying. If you distributed back in, you would get back to this Same exact thing. I'm not changing the value, I'm changing the look. That's what factoring does. Okay, so now we can set each thing equal to 0. 2x equals 0, and 3x minus 11 equals 0. As long as one of these things equals 0, since I'm multiplying them, it'll make a true statement. So I would divide by 2. 0 divided by 2 is still 0, so the first one gives me x equals 0. That's my first possible solution. Second one takes a little more work. I got to add 11. I get 3x equals 11. Divide by 3. And I get my second solution of x equals 11 over 3. Notice it doesn't simplify nice. We always have to simplify if possible, but 11 over 3 have no common factors, so there's no simplifying, and we're done. Those are my two possible answers. Okay, number 2, we have factoring right away. Look for a GCF first. 3, 7, 6, nope, x squared, x, and nothing, so no common factors. So I have a binomial, a trinomial. So I have a 3x and x. That's the only way to get 3x squared, so I can set those in right away. 6, I have 6 and 1. And I have 3 and 2. Okay, remember we're trying to make a 7. So we can kind of think, and it's negative, so one of them is negative, one of them is positive, so we got to keep that in mind. So if I think 3 and 6 make 18, that's nowhere near 7, right? The other one would be 1. 3 is be 18 and 1. Nope. If I did the other one, it'd be 6 and 3. Nope. Next one, I have 3 and 3 make 9 and 2. That's what I'm thinking. 9 and 2 do indeed make 7. I want the bigger one to be positive. So I'm trying that. And then check. Please always check. It's called guess and check. Trinomial factoring, guess and check. So I do the middle term, so negative 2x, and I do the outside term, so that's 9x, and we add them up. Negative 2x plus 9x is positive 7x. That matches. So I know I did it right, because I only use the factors. As long as you only use factors of the first and third terms, and they add up to that middle term, that's how you know you did it right. Okay, so now I know I'm right. I set my two factors equal to 0, because as long as one of them equals 0, it will be a true statement. So add 2, I get 3x equals positive 2, divide by 3, and I get my first solution, x equals 2/3. The other one, I need to subtract 3, and I get x equals negative 3. All right, and there we have it. All right, number 3, we have a problem right away. Remember, it has to equal 0. This equals 28, so I need to subtract 28 from both sides first. So I get x squared plus 3x minus 28 equals 0. Remember, we can only combine like terms, so that would be the like variables. This one has no variables, so it has to go on the end. It doesn't combine with anything. There's no GCF, so I'm factoring right away. Luckily, this is x and x, so start off, this is an easy problem. Okay, so now I just have to look at the factors of 28. So I have 28 and 1, definitely not. I have 14 and 2, definitely not, because one of them is negative and I need to make a positive 3, and it's not going to work. That's going to make 12. Okay, and so then I have 7 and 4. There we go. 7 and 4 can indeed make 3. So I look, and I want the bigger one to be positive, because it's a positive 3, and then we check. Please take the time to check. It's very simple. So I get the middle terms make 7x, the outside terms make negative 4x, and when we combine, we get positive 3x, which does match. I know I did it right. So I get x plus 7 equals 0, x minus 4 equals 0. 0 product property, subtract 7 from both sides, and I get x equals negative 7. That's my first solution. Add 4 to both sides, and I get x equals positive 4. That is my second possible solution to make that statement true. Okay. Number 4, Once again, not equal to 0. I'm going to subtract the 49 because I want the x squared to be positive. That's what I'm used to. So 9x squared minus 49 equals 0. GCF first. It's not a GCF because the only factors of 9 are 3 and 3. The only factors of 49 are 7 and 7. Nothing in common, but notice those factors are duplicates. So this is a difference of perfect square. Okay, so difference of squares, I take these perfect squares, so it's 3x and 3x. This one is 7 and 7, so I have 3x plus 7, 3x minus 7 equals 0. If you wanted to check these, if you did the middle terms, it's 21x and the outside terms is negative 20x. It should always combine to 0. That's how you could check it. And it does work if you do that. All right, set each term equal to 0. Okay, so I'm going to subtract 7. I get 3x equals negative 7. Divide by 3. And I get x equals negative 7 over 3. The other one, I'm going to add 7. 3x equals positive 7. Divide by 3. Whoa, what happened there? I get x equals positive 7 over 3. You should always end up like that, where it's the negative and the positive. Like so. Okay, so I have a negative 7/3 and a positive 7/3. Those are my two solutions. All right, next one. So this is an example of a problem. We usually want the x squared to be positive. So it's not equal to 0, obviously. There's two different things equal to each other. One of them has to be 0. I don't have to always move the right side over to the left. I can move the left side over to the right. And usually, like I said, we want x squared to be positive. So I'm going to move 11x over and 2 over, right? Minus 11x plus 2, the opposites, because that makes 0 on the left. So I get 5x squared minus 11x plus 2. Make sure you are only combining like terms. This is an x squared and x and no variable, so they are unlike. Okay, and then I'm going to factor. There's no GCF, so it's trinomial factoring. So this is 5x and x is the only possible way. So that's kind of nice. So I can write that out. And the other one is only 2 and 1. That's also kind of nice. And they're positive, so they need to be the same sign. Doesn't mean they're both positive. They're either both negative or both positive. And you look at the middle term. Since the middle is negative, that means they're both going to be negative. I need to make 11. So 5 and 2 make 10. So that's why I'm going to do that and make them both negative. And we check, always check, even with these. Negative 1x minus 10x does make negative 11x, which matches. So we do the middle terms and the outside terms, combine, make sure it matches. Okay, then I set up my first one equals 0. Oops, I don't know why I did parentheses. 5x minus 1 equals 0. And x minus 2 equals 0. So this one, I'm going to add 1. And then divide by 5. And I get x equals positive 1/5. This one I'm going to add 2. I get x equals positive 2. All right, last one of these. It moved again. Why is it doing that? Weird. Okay, this one is a lot of people get wrong because they want to just set it equal. It's already factored, looks beautiful, but it is not equal to 0. It's the 0 product property. It must be equal to 0. It's not the 6 product property. It's the 0 product property. It's the only way it works. So unfortunately, this means we actually have extra work here. So I have to distribute. So I get 2x squared minus x equals 6. Then I need to move the 6 over. So I get 2x squared minus x minus 6 equals 0. So they weren't nice to us. They weren't like, oh, they already factored for us. Nope, they actually added more work because they factored when they weren't supposed to factor yet. Okay, so now I have to factor, so I get 2x and x, because that's my factor of 2x squared. It's the only possible factor of 2x squared. And I have 6, so I have 6 and 1 and 3 and 2. I know that I'm making negative 1x. It's probably going to be the closer ones together, so I'll try that. So if it'd be 6 and 2, that doesn't make negative 1. Or if I do the other one, it'd be 3 and 4. Yep, there it is. That's what I want to make negative 1. I want the bigger one to be negative. And when I multiply, that's what makes that 2 bigger, right? So it's positive 3x, negative 4x, negative 1x. Remember, if this is hard, that is okay. You're not meant to be as quick as I am at factoring. I have literally been doing factoring for years. Practice. That's the only way to get better at factoring, is practice, because you just start seeing the patterns, understanding what things do with the positives and the negatives. Practice multiplying in your head beforehand. Takes time, but you can get better at it. So subtract 3, divide by 2, and I get my first answer, x equals negative 3 over 2. And the last one, I just add 2, and I get x equals positive 2. Those are my two solutions. Okay. All right, now we're going to talk about square roots. So for problem 7 and 8, solve by square roots. Remember that if x squared equals 25, so hopefully you know this, if I have x squared equals 25, I need to get x by itself, so I got to square root both sides. Whenever you square root both sides, whenever we square root both sides, we need a plus or minus. So remember, that means both plus or minus. So when I square root both sides, I get x equals positive 5 and negative 5. We're going to write out two things. We need plus or minus. I'll actually write it out like this. Plus or minus. Okay. So the solution here is 5 and negative 5. And you can check it. If I plugged in negative 5, right, I'm squaring the negative, so negative times a negative does indeed make a positive 25. And then the positive 5, obviously squared, is also 25. Okay, but obviously we're going to have a little more complicated. So first thing, like the absolute values, we need to get the squared thing by itself. So we do not distribute. You have to get the squared thing by itself. So I get x plus 3 squared equals 25. Get the squared thing by itself. Now we square root. But remember, new thing, whenever we square root both sides, we need plus or minus. So I'm actually going to set up two things. X plus 3 equals 5. And x plus 3 equals negative 5. Okay, plus or minus. Square root both sides makes plus or minus, just like absolute value makes plus or minus. Okay, and then I can solve. Subtract 3. I get my first solution of x equals 2. Subtract 3, and I get my second solution of x equals negative 8. Which, if we plug those into the original problem, we could see that they do work by checking. But whenever you square root both sides, you need plus or minus. Because that's squared, we'll turn whatever the negative is positive, because negative times a negative makes a positive. Okay, so number 8. I'm going to subtract 7 first. Then divide by 2. I get x minus 6 squared equals 20, right? We are not distributing, we're not combining, we're moving things over. Then solve by square roots, square root both sides, and I get two equations. X minus 6 equals square root of 20, and I get x minus 6 equals the negative square root of 20. I'm writing out the square root because it's not a nice number, and that's going to happen sometimes now. So we need to know how to write out the square root of 20. Might need to make a factor tree if that's what you need. So 4 and 5, 4 breaks down to 2 and 2. We're looking for pairs. I have a pair of 2's with the 5 left over. So the square root of 20 is 2. One of the pair comes out with a square root 5 left. Whatever is left stays inside. So you need to know how to simplify square roots. So 2 root 5. So I get x minus 6 equals positive 2 root 5. X minus 6 equals negative 2 root 5. And then I add 6. Combining like terms, I do not add the 2 and the 6 because the 2 has a square root with it. They are attached. We cannot combine those. So it's x equals 6 plus 2 root 5. That is the normal way of writing that. And the other one, if I add 6, once again, we cannot combine the negative 2 and the 6 because they are unlike terms. So I get 6 minus 2 root 5. All right, number 9 and 10 is practicing simplifying things. I would highly recommend you separate with big fractions. You separate. This is leading up to solving by quadratic formula. So when I separate, I get 4 over 6 plus 18 root 3 over 6. Everything is divided by 6, and then I just simplify. So 2 goes into both, so 2/3 plus, I can divide them. I cannot add or subtract them, but I can divide them. 18 divided by 6 is 3 root 3. So make sure you understand that. When we're talking about combining like terms, we're talking about adding or subtracting. We can still multiply and divide things, but adding and subtracting must have like terms. The last one, number 10, so this might look familiar. We have to simplify this big old square root looking thing. So I have negative 4 times 2 times negative 3. Negative times a negative will make a positive. 4 times 2 is 8 times 3 is 24. All over 4. So then we combine negative 6 plus or minus the square root of 60 over 4. We have to make our factor tree for a 60 to find the square root. So I got 10 and 6, 2 and 5, 2 and 3. So I have a pair of 2's with 15 left over. 5 times 3 makes 15. So that ends up being negative 6 plus or minus 2 square root 15 divided by 4. Then we separate negative 6 over 4 plus or minus 2 root 15 over 4 and simplify. So I end up with 2 goes into both, so negative 3 over 2 plus or minus the square root of 15 over 2, the 2 and the 4. That is one way to write the correct answer, but usually I actually write them out separate. You can write them as one combined thing, but I usually write them out separate because it helps me remember that there were 2 solutions, right? I have 2 solutions, plus or minus. This little symbol means the first one is negative 3 root 2 plus root 15 over 2. The second one is negative 3 over 2 minus root 15 over 2. That is the same thing, so it's either one of these. You can write either one. You don't have to write both, either one. But you need to understand that plus or minus means plus 1 and the minus 1. 2 solutions. Okay, so you have plenty to think about. Your essential question, don't forget, write a 3-sentence summary.